We're all packaged with regrets. Um, I like to do these lecture videos to help ease your mind with things. And this one can be a little bit disjointed because I'm going to, as you'll see when I scroll down, have additional items such as this dot paper when I go through. So hopefully you're able to connect dots when you do that. And my regret is that I didn't prepare how I would do these lecture videos before I actually gave you the handout itself. And I know that I don't have, I know that I didn't allow you to have a lot of space in your stuff. So it's going to be, unfortunately, up to you to figure out how to manufacture that space when you go along with the things I talk about. And much the same, some of the things that we go over in class. For instance, we talked about 9.2 right here in class, and 9.3, even though we skipped some parts, I still want you to be able to cover the things that I kind of mention as if it's a handout. So even though I don't actually cover it on this sheet, like here in 9.2, we started talking about side and top views, okay? I want you to make sure that you know there are things that are also your responsibility as you go. So we started to do these drawings right here, figuring those out. And we talked about them. And this isometric view is different than the one on the dot paper as well. But we have some work to do. Anyway, this is still a part of N number 14 about constructions of solids, only this is like a part 2. And not necessarily on the top right here, but what I'm working with here is volume and surface area. Now, as I go along, I will keep drawing map plans and isometric drawings and such to make sure that you get a full understanding of it. And this online lecture is going to be significantly longer than the class lecture because of how I'm going to go about my business here. In fact, we might not cover everything in class, which is why I want to refer to the online stuff. Okay, first of all, with volume, let's see if it's on this page. It is not. I'm not going to the webcam for more reasons than one, but one of them definitely being that the webcam didn't really work well with my microphone last time, and I felt really bad about that. But I'm going to refer to these cubes and drawings, and I hope that you get a good understanding now of what they look like based on the look of cubes before. This here is one cube. Okay? And a cube, I kind of gave an unoriginal definition before, but a cube by definition is a prism, which we'll talk about, where both of the bases of the prism are squares, the top and the invisible bottom, and all of its lateral facings are squares. So every face is a square. Now these are things that I haven't yet defined for you. So we're going to define them together, I suppose, and there's somewhere where you want to write them. And I don't have any formal definitions. I could go and Google them, but I can show you what they are as we go along. So a cube is basically like a 3D square, if you think of it like that. So for instance, this, if you assume things are closely drawn to scale, this is not a cube because on the top and bottom here, I'm not looking at a square. I'm looking at a rectangle. A cube has to have squares everywhere on all 6 facings. Okay, and a cube, then, in this sense, we're going to say that these are unit cubes. And unit cubes mean they all have length and width and height of 1, and depth of 1, and whatever else you call it. So all of these are a size of 1 unit. Okay, so each cube, the volume of a cube, by the way, or a prism itself, I suppose, you take the length, multiply it by the width, multiply it by the height, or whichever way you want to put it. You can say depth, you can say anything else. But basically what it is you take a square, and I'm doing this in 2D. Think of this like a 3D drawing, but it's laid down like a flat piece of paper. Let's say the square has length of 1, height, or in width of 1, or whatever. So this is 1 times 1. So the area of this square is 1. Okay, now I'm going to take this square and then I'm going to grow its height upward. If you can see that. Okay, I grow this upward and I connect them all, and there's my cube, if that makes sense. Let's say this one up 1 as well. So we did length times width, which was 1 times 1. That's the area of my base. This bottom portion is just the base. And then I grow my base up by 1 in every direction. And this is also 1 as well, etc. So I take this base and multiply it by the height, which is 1. So the volume is 1 times 1 times 1, which is 1 cubic unit. That U cubed is just 1 cubic unit right there. Okay, so that's the volume of my entire thing. In other words, if I had a cube, let's say it was some sort of box, and I opened the lid to the box and I poured water into it or sand into it or anything else like that, and they're 1 cubic unit all the way around. Let's say it's 1 foot. It's 1 foot by 1 foot by 1 foot. The amount of cubic volume that I poured in there, if I filled it all the way to the top, is 1 cubic foot. Okay, so that's what that means. It's the inside fill. So I've talked about individual one-dimensional units, length. It's in terms of what you can measure in length. Okay, it's how far does it go, the distance. A square unit is the amount of cover. When you're talking about area, you're saying how much can I cover. And cubic units are how much can I fill if I can put it inside in 3D, in our world. Okay, so that's what volume's all about. Okay, we did these map plans, but we're going to find the volumes of them as well. Or we didn't do them through online lecture, but I asked you to do them. And you know what? I think I want to do this down below as well. We're going to do 3-dimensional solids. And let me, I'll zoom out a little bit for you. Let's go to 75%. Well, that's a little far back. Let's see what 100% looks like. Fair enough, I can see. Okay, I'm gonna do because we did this one in class probably. Let's go all the way back to this one. Okay, I can do an isometric drawing. Now this one's actually gonna be a little hard for you to see here. If you haven't tried it yet for yourself. Here I have the front and the right. So when I do this here, let's go with the front and the right. Okay. And I'm going to have this corner represent this corner here. So here in this corner, we have a 1-story building, if you will. So 1 cube going out this way like that. So I'm going to start drawing it up this way for good reason. In fact, you know what? This might be too far up. Let me completely redo all this. Let's go down a little bit more. Okay. I'm going to start in that corner again, right here, and I'm going to make that 1-story cube to get me started. Okay, this will be important as far as what I do behind it. Ugly cube to start. Very, very poorly done. Okay, there's there's a 1-story cube. Behind it here we have a 2-story and 3-story cube. So we'll go up here. The 2-story cube's right here. 2-story building, if you want to call it that. Gee, when I zoomed out, it made this a lot more difficult to draw. And the 3-story one. And again, this comes with practice. As far as perspective and when you need to erase, when you need to do different things. So there I just covered all 3 of these guys on the right. Okay, now I drew these in front because everything else lurks behind it. For instance, these are 0. That means there aren't any cubes here. So when I draw this depth here, you're going to notice there won't be anything right here. I'm not going to draw anything right there on the 1st story because there's nothing there. It's invisible. But if I go back one right here, now this is where the base of this 1-story building is. Okay, in the back. Let's see, did I do that right? Let's see, here's one. No, I'm sorry, the 1-story building would be right here. Okay, so here's a dot that represents 1 layer back. Here's another dot, you can't see it, but it goes 1 layer over. Now when I start drawing this 1-story building, it starts right here. So here's a 1-story building. See, even I have trouble with it sometimes. So that's this guy right here. Okay, and then a 2-story building behind it. Or to the left of it. Here's a two-story building. Definitely something that's going to take a long time to practice. That's why we're going to do a lot of these together in class. I might not even go over surface area on this day. And then I have one-story buildings in the third, three things back. So it's going to line up with these. So it'll line up in the front. It'll line up with these. So I go one over. Here's another one over, and I'm going to draw a one-story building there. You won't be able to see that one. If I go one more over, I have another one-story building that's behind it. If I drew it, it would look like it would go back here. So again, this is a really difficult drawing to perceive, extremely. Zigzags all around. That's why I'm doing it with you. And I'm going to start by drawing facings as well. Like the front facings will be in red. Okay, so let's start to get a hopefully little better idea of what this drawing really looks like. So here are the ones in the front. This was a one-story building here. This was a one-story building here. And behind it we had this and this. So this is all you can see on the front. Let's do purple for the right. Right facings are here. Here. Okay. And again, it's all about perspective. You're going to say, well, where are some of these diagonal lines coming from? Like that one way back there. You might have got extremely lost when you saw that, and you still might be. Try and give you as much help and guidance with that as possible. Okay, so I've covered all my visible facings. Now see if you can get a better idea of it. Because remember, isometric drawings have some obstructions, and I'm not using cubes this time to help you. So let's get a better idea of this. The very, very front, from left to right, should be 3 rows. The only thing is this doesn't have anything here. So when I mean 3 rows is that when I look at all of them, I'm looking at 3 layers deep. So let's even go one set of cubes back to the 2, 1, 2 right here. That refers to, if this is the front, and this is that front row where there's nothing there until I get here. So nothing, nothing, and then 1 story. That's the front. In the back, this is a 2-story building. Next to it, right here, is a 1-story building. You can see it right there. And next to the 1-story building is this 2-story building right here. Let's use black and circle it. So this 2-story building behind this 1-story building right here is right there. And behind that is a 3-story building. So maybe you can see these front guys right here. And maybe you got a good idea of, okay, I can even see those ones as well. I got a good picture of those. The hard one is there's a 3-story building back here. And remember, the way isometric dot paper works is you go diagonally. So there were dots here, 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 etc. These all go in a line. You can see this line. Whoops. You can see this line. Let's do an actual line. You can see this line going down like so. So if you were to think about it, when you do 3 stories, look at where these will connect. So this represents the base of my 3rd-story building. If I wanted to reconstruct my 3-story building here with this black, you can see this is where the base is. So everything else in line with it will be the base of the other buildings that are 3 deep. So the 1-story buildings will have a base that goes down here. Okay? So when I do isometric drawings, what am I erasing? Whoops. So when I do isometric drawings here, of those 2 1-story buildings way in the back, they are going to be, here's 3-story building. A 1-story building will be right here that I can't see. I could have drawn the cube, but it would have been nothing because all you see here is the 2-story building right there that's blocking it. I can't see it. The other one is back here. It looks like this. Okay? And again, I'm obstructed by this 2-story building and this 1-story building in front. So that's why I can't see any of this. What I can see, though, is this green in the back. Part of the ceiling of this 1-story building is in view in the isometric drawing. So both of those are back there. And you know, as I said again, here's the 3-story building that's right next to them. Okay? So here they are way in the back, but they aren't in view. At least not fully. Okay. So there's my isometric drawing. And pretty difficult to see. Okay, what was the point of that? Well, I want to find the volume. Now volume, as I said, if all of these were cubic units, if all these were unit cubes, that means everything's measured by ones. Then the easiest way to find the volume of this is ask myself, well, how many cubes are in this entire shape? Okay, again, if these are all 1, this is 1, 1, 1, 1, 1, 1, etc. So all these are 1s all around. So if I want to find the volume of this cube, it's 1 times 1 times 1, so it's 1 cubic unit. So all of these are 1 cubic unit, and all of them have a volume. So all of them have a volume of 1 cubic unit. Now you count how many cubes there are. Remember, just like with area, if I want to find the area of this shape, I can separate this into 2 different shapes. Find the area of both, and then add them together. Maybe I find the area of this triangle, then the area of this rectangle. And then I add them together. That will give me the total area of the entire thing, which will come into play in just a bit. So all these are 1 cubic unit. So just add how many cubes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the back, I have 10, 11. It's behind there. If you can't see it with the isometric drawing, that's fine. You can go ahead and look up here again. This represents how many cubes there are, really, because it says how many stories there are and how deep it goes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 cubes, all with 1 cubic unit in volume. So total volume equals 11 times 1, because each volume is 1 cubic unit, which is 11 cubic units. Okay. Draw the front, right, and top views of the solid on a piece of graph paper. Right now I'm going to skip it because you've done a couple of those before. Maybe if I run into another one where it will be more important to find the volume, I'll use that. In fact, I'm going to do this one now, 9-4. Excuse me, I got any on there. 9-4 will hopefully help me do the thing that I just said, because it still represents front, right, and top, and we're still practicing it. Okay, and we're going to work on volume once again and doing isometric dot stuff. So I'm going to bring this down in case you need it again, in case you want to look at it, because I'm going to do this next problem. Megan built a shape with blocks and then drew the views shown at right. Build Megan's shape using blocks provided by your teacher. Use as few blocks as possible. So I'm not going to give you blocks. So just build Megan's shape. We're going to draw it on isometric dot paper. We're going to practice. Okay, remember, front and right. Let's get it started. Let's hope I have enough room. I probably don't. Let's go down a little more. Okay. The front goes across 3 blocks. 1, 2, 3. That's my base of these blocks. Remember, if this is my front, then this is the right of the front. Well, I should just look here. This is the right of the front. And on the right side, on the rightmost side, remember this is the top, this is how high it goes. On the rightmost side, the blocks look like they can get up to 3 stories. And on the leftmost side, they look like they can get up to 2 stories. And in the middle, in the middle, they look like they can go up to 1 story. So when I look at the right here, remember, this is the front when I look at the right. And the right goes all the way back 3 blocks in depth, as far back as possible. Not that necessarily on the right that's the base, but it does go back that far at some point. So when I cover all this, the top, you can also see where things go. This is the front on the top, and this is the right. So on the front and right, that'll help you best for the top. The top will help you best to see the front and right. So here's the front, here's the right. They all have blocks containing them. So I'm going to start drawing that base. I know my explanation is kind of poor. This is actually my first time looking at this exact problem with you, which is why I'm kind of having trouble explaining it to you. But the top will help you get the best coverage and understanding of what's going on. In the top middle, from the top, in the very middle, there is not anything there. So there won't be anything you can see here, except for maybe blocks that are in front. And again, my drawing today is extremely poor. I do apologize for that. Let me try that again. Okay. There won't be anything there. There will be a hole, which you might not be able to see from the isometric drawing, because there will be a cube I'm going to draw in front right here. And in the way back here, there won't be anything, cube-wise. Okay, in the front, I have a two-story. No, I'm sorry. I don't have a two-story. In the front, it goes up 2 stories. But you can see on the right, if this is the front on the right, then you can tell everything in the front looks to be only 1 story. Because if this is the front, all of these guys right here, all these must be 1 story, because from my right view, right here, I can't see anything else that goes upward. So I'm going to draw these all the way across, like so. And we're going to get 1 story all the way across. Okay. Now on the right, you can see they go up as many as 3 stories. Okay. In the next row. So it goes up as many as 3 stories, and the front shows you, oh, by the way, this thing can go up as many as 3 stories on the right, so this right one, the second one, must be going up 3 stories right here. 1, 2, 3, goes over. And again, my explanation might not be best. You might have to look back at this a lot. This comes with a lot of practice, calculation, fallback understanding, and erasing. I might screw up somewhere here, okay, which I want you to know. Now the front also shows that it goes up as high as 2 stories. Now in the first story, the front only goes up 1 story. That's what the right revealed. And then when I go back 1, it shows it go up 3 stories. In the top, it shows I have 1 block here, no blocks here. I have 1 block here, nothing here. So this second one must be 2 stories tall, because in the front it says, if somewhere I can see 2 stories, and the first one in the right, there's only 1 story, then this one must be 2 stories. And remember, there's nothing right here. So I'm going to go ahead and start drawing this one right here, and this is 2 stories. What you do in the back, and I go along and connect dots. Okay. Maybe I should have built this. And here's the front, here's the right, going all the way back, 3 rows back, right here, there's 1 block. This 1 block might be 2 stories, or it might be 1 story. How can you tell? Well, there's 1 more block over, and the front tells you in the middle that it only goes up 1 story. So this one only goes up 1 story, therefore this one must go up 2 stories to say these go up 2 stories, because there aren't any blocks here. So this one goes up 2 stories on the farthest to the right, and the one behind it, which you cannot see, doesn't go up, or only goes up 1 story. It's invisible. If I were to draw it, I would be drawing it right here. I suppose, no, let's see. Yeah, I'd be drawing it right there. Invisible. So this is my isometric. Something just spooked me out. It was the heater or something like that. I have no idea. Anyway, start doing my facing. See if you can make sense of the drawing, because it might be kind of weird. And by the way, not everything's going to be filled in. You'll see why. There's going to be one part left out, actually. Front I'll do in red. Right I'll do in purple. Top I'll do green. Now drawing this was kind of tough. All right, you have to spend some time and say, how do these things connect? What makes them what they are when I look at front, right, and top, and why are they all necessary, and how do they help me get a good understanding of what I've drawn? Oh, I'm missing a purple. So check this out. You might think this is a ceiling, but I'm going to tell you right now it's not. It's a facing. It's a right facing. Here's why. Remember what I said in the middle, there's nothing there. So if there's nothing there, the building that I want to look at right here will be completely visible on its right wall. So here's this wall, and here's the other wall below it. There's no ceiling here. This is not a 1-story building. It's a 0-story building. So below it, if I went down, if I could rotate this, there's a center court. I don't know what it is. but there's nothing there. So this is a wall that you can see, and if I could go inside there, I could go inside right here. Remember where I said there wouldn't be anything here? Inside there, here would be the wall, and here would be that court. Okay? That's why I'm not drawing green on top, because this is not a ceiling of a one-story building. Now there's stuff behind it which you can't see. I would prefer that I could draw the left in front and stuff as well, so you get a good example of what this whole thing is. For the sake of time, I'm not really sure. I mean, this lecture is kind of going to go a while, because it's just a broad explanation. It's going to go a lot longer than when we do in class, because we're probably going to use cubes. Okay, what's the volume of Megan's shape? This time I'm going to change it a little bit because I want you to practice volume in a different way. Now these are cubes though, so I'm not going to change it too much. I'm going to change the units, and I'm going to say these are not unit cubes. They are 3 units every way, in every direction. So all these are 3, which means these are 3, etc. So we're looking at things that are 3 by 3 by 3. So the volume of any one cube is 3 in length by 3 in width by 3 in height, which is 27 cubic units. In fact, here, let's call them inches, cubic inches. That way we're practicing. What's the volume of Megan's shape? Well, what I'm going to do is I'm going to take the volume of 1 cube, which is 27. Excuse me. Now your purpose is to count how many cubes there are. And using blocks, that'll be really easy. Using this, you have to remember exactly what you did here. So in the front, I have 1, 2, 3. Here I have 4, 5, 6, 7, 8. In the center, I have none. Okay? In the center, I have none. On the back left, I have none. Here, I have 1. Because if you remember, this represents the... This represents the middle. This represents the middle. In the middle, there's only 1 story on both, so these both must be 1 story. Is that 9 so far? 1, 2, 3, 4, 5, 6, 7, 8. So 9 back here. 10, 11 down there. So there are 11 cubes again, because there's none in the center and there's none over there. So the total volume, I'll just put volume again. It's 11 times 27, which is 297 cubic inches. Okay, now unit of measurement's important. They're cubic. I know you could say inches cubed. That's fine. So anyways, so I did that. Excuse me. So I did that math there. So let's say all these were connected. Let's say that this was some sort of object, and I opened the lid right here, and I poured water inside, and it filled it all up. This would be equivalent to having a cup with the same volume. So if I pour water into a cup with the same volume, they should fill up the same. And that's how volume works. We're going to have to experiment with it. Maybe someday I'm going to bring certain things and we can actually practice it in a better way. Okay, and like I said, this is very exploitative in these lecture notes. I'm sure you're not going to have very much fun listening to it because it's just a lot to say and not that much to do. But I'm going to move on, and I'm going to go surface area and stuff. And like I said, this is I went to volume without doing this volume portion. So, I mean, we're going to do a lot of exploitative practice here, and I feel like I'm going to cut some of it out. Okay, draw the map plan. Okay, a map plan's always going to be from the top. I don't think I was very informative with that. I'm doing A, by the way, when I draw it over here. I don't think I revealed that enough when I was talking about drawing a map plan. So most of these look like they go 3 by 3 when we do these. It's kind of interesting to note. So in a map plan, they want you to indicate when there is 0 of anything. Now it says there may be more than one possible answer. We talked about that before. Oh, by the way, you know what? I think we did this one in class. I'm gonna do B. Okay, so in B, there might be more than one answer because sometimes there will be things that are obstructed and you can't see them. In B, I don't think that's the case. I think I'll be able to see everything. So in B, you can see in the front here, here's 1 story building, 0 story building, 0 story building. So this is a 1, 0, 0. In the next row, it's 1, 1, 1. In the back, it's 3. Nothing here that I can see. So it's 0 and 2. So actually, that was pretty easy. And then find the possible volumes. Again, you find the volume for one cube, whatever the length is. Let's say it's 5, which means it's 5 all around, 5 by 5 by 5, which is 125. Let's say it's even cubic feet. Awesome. The volume then is counting the number of cubes. I have 1, 2, 3 below it, 4, 5, 6, 7, 8, 9. So I have 9 cubes, all of 125 cubic feet. So the volume, you multiply that and you get some number. You get 900 plus 225, 25 cubic feet. Okay, that's an example if they're 5, if the length is 5 by 5 by 5 by 5, etc. Okay, so that's how volume works. I'm going to go into surface area, and I think I want to speed it up. I'll do one last problem with you. See what else is there. Oh my gosh, I have so much to talk about. This is a long lecture. Surface area is the way we're going to talk about it in class. I mean, when we do more practice problems, is like wrapping presents. Okay? If I were to have a present, let's say it was a box. Let's say it was a shoe box. Okay? If I have a shoe box, gosh, I'm not drawing well today. If I had a shoe box right here, and let's see, this goes up 2. I'm so sorry about this. Okay, I have a shoe box right here. What I want to do, in essence, is find out like how much wrapping paper I need. Now remember, wrapping paper is a two-dimensional concept. It's saying, how much do I wrap right here, and here, and here, and the other 3 facings? It's basically, how much paper do I need to cover each portion of this box, of this shoe box? Now remember, the shoe box goes all the way around. There are invisible portions here, and here as well. And it says, how much paper do I need to cover that side? And by side, these are called faces, really. How much paper do I need to cover this face? How much paper do I need to cover this face? Etc., etc., etc. Okay? Now, in any rectangular prism, meaning the rectangles all the way around on the sides and stuff like that, there are 6 faces. Count them up. Here's 1 on the top. Pretend like that's the top. 2, 3 on the bottom. 4 on the back. 5, and on the left here 6. Okay. Oh gosh, excuse me. Once again, I'm terribly sorry. What I'm going to do for you here is I'm going to start drawing drawing them like cubes on the front, and we're going to practice this other new kind of drawing. It's going to be called a net drawing. What a net drawing does is, what the heck just happened? What a net drawing does is it unfolds your box into a two-dimensional appearance. Okay? So here you have all these things right here. What if I took this part and I started to unfold it this way? So check this out. If I take this 2x4 part right here, what if I removed it like so, and I folded it and I unfolded it outward? So I extended it out like that. Okay, does that make sense? I basically opened up the box, and let's say there's something below it right there, right? Oh gosh, why does that keep happening? I have to work on my undo button. Okay, but there's still something below it, so I'm going to deepen and darken this, and below it's this part, which is, well, it's really nothing down there. Okay, what if I took this part here and also unfolded it upward? So I'm going to erase it down here. Okay, that was 2 out this way, and it was 3. No, it was 2 and 3 across, yeah. So I'm taking it and unfolding it upward. Makes sense? Now on the bottom here, can't really see much. Now there's a backside too. You see, this is also 2 by 3. I'm going to remove that and unfold it out this way. Like so. Okay. And I take this one right here and I unfold it out this way as well. Now there is one portion that I'm missing, and that's the very bottom. That's why I want to keep drawing this down here. The bottom was also the same as the top. So let's take the bottom and let's unfold it out with this as well. So this was 3 by 4. So it goes 1, 2, 3 by 1, 2, 3, 4. And it looks like so. Okay. I took what was originally a 3D shoebox, whatever it was, and I unfolded it. I opened up the box, and here's what's left. This is called a net drawing, although our net drawings are going to look like this, more so. It'll be like, if I take this right here, and this was the 3 by 4 top of the box, of the box. This is probably the worst prepared lecture you'll ever have. I really do apologize for all of it. Okay, here's the 3 by 4. I unfolded this portion right here, so that's going to be drawn over here. I unfolded the back portion over here. It's going to be drawn over here. Let me close it up. This was a 2 by 4. 2 by 3, I'm sorry. I unfolded this portion. Let's do that down here. This was a 2 by 4. I unfolded this portion up here, also 2 by 4. Okay, and I unfolded the bottom as well, which was a 3 by 4, just like the top. Okay. This is called a net drawing, and basically what it is you take whatever you had as a 3D shape, and you say, what does the surface look like? Like on the surface level, if I were to unlayer everything and unravel it, just like a shoebox, whatever, if you were to unfold it, what can come of it? And this is a poor drawing. And it's hard for me to manipulate without you seeing exactly what I'm looking at here. But I'm looking at 6 facings. Hopefully, it'll make more sense when I do it right now. Let's do that again. Make them blue and kind of bolder. Here's one facing. This was the top. Here's a facing. That was the side. This is the bottom. Oh, you know what? I didn't even finish the bottom. That or I undid something. Here's something, here's something, and here's something. All right. Imagine the ways that you can fold this. If I take this top, let's say I folded these back downward. Remember, let's say I took this portion right here and folded it. So let's say I took this portion and folded it downward like that, like back down. Then it would close back up right down there. And then I took this portion right here and I folded that one underneath again. Then it would close up down there. Okay. Hard to see, hard to imagine on here. I'm sure there are animation things that I'm going to link to because this lecture is way overkill right now. Worst lecture I've ever done, and I self-admit it. So if you have questions on this thing, I mean, gee, this is going to be an in-class type of thing to talk about. I'm going to figure out how to do the review when I have to. Probably going to refer you to a video. Anyway, the whole point of what I'm doing here is we're talking about surface area, saying if I had like Christmas present paper, wrapping paper. I have this whole roll of wrapping paper. It's like that. And I'm going to unfold some. I'm taking some out. And I need to cut it out. How much paper do I need? Well, normally they cut out this much, and then you fit it inside your box, and you wrap it, and you cut out, and you fold over, and whatever else. But if you wanted perfect amounts, all you need is just enough to fill out the outside of it. So to fill out the outside of a shoebox, again, if I redraw this thing, well, that's not perfect. If I redrew a shoebox right here, I have to cover the top. Covering the top is just finding the area of the top. Covering the side is just finding the area of the side. Covering the front is just finding the area of the front. And then there are 3 more sides to consider way back here, and you have to cover this one, and the bottom. Let's say the bottom's over here. So I have to cover 6 facings. All I have to do is find the area of each. So when I do this one right here, if this was some sort of shoebox with this kind of stuff, I just have to find the area of this. Let's say this is 4 by 3, which is 12. So let's say the area of this is 12. The area of this one, I believe this was 2 right here. Let's say this was 4 by 2, which is 8. And I undid a lot of things by accident. 3 by 2, which is 6, 6, 8, and 3 by 4 again, which is 12. These are the areas of all these. So then I add them up. 12 plus 8, 20, 26, 32, 40, 52. So the area of this entire object is 52 square units. So that's the surface area of this thing. I'm going to call that SA. Surface area is finding the area of your surfaces. The reason why I had to do all this was because you're going to work with things called net drawings, and I'm going to save it for you for later. This was terrible for me to explain on paper without being concerned about it beforehand. I didn't think too much about it in depth and how difficultly this would go. So I'm going to make sure that I get a better explanation in class. Because I'm going to say you can watch this online, but it's not going to be of much benefit. And I can't even move it, so I'm not even going to worry about it. In fact, I'm just going to delete that. You can rewind if you need to look at that. I'm going to do this one problem and then be done. Because you won't even need it for today. Okay, we're going to do one more drawing. Gosh. I'm going to do one more drawing using these. And then I'm going to skip drawing the map plan. And then we're going to talk about surface area. Okay, this problem will make a little more sense, hopefully. I hope. Oh, actually, this problem's going to be a little difficult. Okay, so we're going to do a drawing based on this. Let's see if we can make more sense of it again as we try it. Here's the front and right. Okay. That's why we need to use building blocks. So we're going to practice with those in class. On the front, it goes 3 across. I'm sorry. If this is the top, here's the front. Here's the right. Okay? The top's going to help you get the best understanding of how to lay out your map. So the top, the front left is covered. So I'm going to start with that base right there. And then you can see it goes back. So it goes here, and then it goes back. And then it goes over and back. So it goes back 1, and it goes back 1, and then it goes over 2. 1, 2, and then it goes back 1. Okay. Now I'm going to use that because it goes back here, but I can't see it because I'm going to draw upward. Now I'm going to use the top, the front, and the right to get a better understanding. Excuse me. To get a better understanding of what everything else looks like here. So from the front, I can see that everything's covered at least 2 stories. So everything here might go at least 2 stories. But on the right here, in the back, it goes only 1 story, yada, yada, yada. So I'm going to look at this front right one, this one individual cube, because there's only one of them. If there's only one and this is the front, and I'm looking at this from the front, then that front right one must be 2 stories tall. So this front right block must be 2 stories tall right here. My drawings, I'm trying to figure out why this is screwing up so much. It must be the view, the perspective that's distorting this today, because I can't even draw straight. That's 2 stories tall. Okay. This one next to it, on the front I see 3 stories. On the right middle, I see 3 stories. So I'm making an assumption right now that I'm looking at this guy having to be 3 stories tall. And if we have a problem with it, we can erase it. Okay. That guy's 3 stories right there. On the front, this is 2 stories. And on the right, remember, this is the front. If I'm looking at the right, this is 2 stories as well. So this front right block is also 2 stories. Okay, so that's what I can see so far. Excuse me. Now on the top, it shows 2 other guys in the back here. And on the right, it shows 3 stories and 1 story. So in the very, very, very back, one that I can't see way back there, there's a 1-story building. Now, there's some ambiguity here. I have no certainty of what this one is here. This could be 1 story, it could be 2 stories, or it could be 3 stories. It can't be 0 stories and it can't be 4 stories, because on the right you can see it only goes 3 up. So this is an ambiguous number of blocks that I could choose. I could choose 1, 2, or 3. Only that in part A it says use the smallest number of blocks possible. So here I'm just going to say this is a 1-story building back here. Because you can see again from the right it says 3 stories, but this guy's obstructing anything behind it, so it can go as many as 3 or as few as 0. But on the top it shows, oh, there's at least 1 there. And on the front it shows 2 stories, but that's from this front one right here. So I'm going to use as few blocks as possible. I'm going to say it's a 1-story block. Same with the very back. At the top right there. Well, I'm sorry. The back of the very top must be 1 story, because the back right shows there's 1 story and there's nothing else there. So we're done drawing this, but there are 2 blocks back here that I can't see. No, I'm sorry. We're not done. Yes, we are done. So we're done drawing. Again, 2 blocks you cannot see. So here are my front ones. My right ones. And my top ones. And again, my regret here is that I can't do as much with you as I wish I could. I really do have regrets about that. What's the volume of a solid? Let's go back to say they are, oh my gosh. Let's go back to saying they are 1 by 1. By 1. So everything is 1 cubic unit. So count how many there are. There's 1, 2, 3, 4, 5, 6, 7. And there are 2 in the back. There's 1 back here. That's 8. Again, it can't be seen. And there's 1 back here. That's 9. So you have 9. So volume equals 9, let's say, cubic units. Okay, draw a mat plan. Be sure to indicate where the front and right sides are located. Did I say I'll skip that? No, let's not skip it. Let's just do it. Let's draw it from the top, like a 3 by 3. There's a 2-story building, and 0 and 0. There's 1, which you can't see, then 3, then 2, going across. Remember, this is from the top. Here's front, here's right. And in the very back, there is 1, which you can't see, and 0 and 0. Remember, these should match with the top. There should at least be numbers that are non-zero here, and these should be 0. And then you have to figure out the rest. There's a map plan. Okay, oh no, Heidi accidentally drops her entire solid into a bucket of paint. What's her surface area? That is the area that is now covered in paint. So that's the important part here. We're saying, what's now covered in paint? So if I dipped a shoebox into paint, all the surfaces are covered in paint, and you're finding the area of each individual surface. And we'll talk more about surface area as we go. But remember, this thing's all dipped into paint and stuff. This is going to be a little difficult to talk about because you need to count how many facings there are. And I can't see it from here. You'd have to do it with actual cubes, kind of. But let me show you the actual facings that we can see, and then we'll see if you can figure out the rest. So here I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15. Okay. If I went around the backside, okay, remember this is a 2-story building. If I went around the backside and look at these facings back here, there's 16 and 17. All the way back on the 3-story one with 0 here. all the way back here. I'm going to count these ones. 18, 19, 20. Now, there are one-story cubes, like I said, back here. Gosh, this is going to be impossible without cubes. Here's 21. Here's 22. Here's 23. Now, remember, this is covered with this building right here, so you can't have that one. None here as well, but on the outside, there's 24 and 25. And on this one right here, on that side, there's 26 and 27. So there I'm counting 27 all the way around it. Now I didn't count the bottom, so I need to start counting the base, which is everything here, and here, and here. So I got 28, 29, 30, 31, 32. So I'm counting 32 facings together. And it's tough with this perspective. I don't expect you to know this, really. I'm trying to see if I can talk about it. So 32 faces, all with area of 1, because it's 1 times 1. So the surface area equals 32 square units. So if I had unit paper, if I had paper, I'd need to cut out 32 square units, or 32 squares of 1 unit each to cover it all up. Actually, you know what? I'm not sure if I counted these two back here. So 34, I think. 34 faces. Okay, surface area is something we're going to talk about more. This is a terrible example, and I'm going to link you to some videos to help you out, because this was pretty poor, and I do apologize for it. Hopefully it was of some benefit to you just to listen to it. Otherwise, it's probably an hour wasted. Good luck. Your homework's not too much about this anyway. We're going to do it more on Wednesday.